So now let's see how do we make updations and deletions in an index. Okay. Index insertion. Okay. First we will see how do we do for a dense index. Okay, dense index has an entry for every search key value. Okay, so if, let's suppose there are two cases here. If entry is present in index, then I would see if I store pointers to all the values. Okay, if I have 432 3 times in my file, then if I store pointer to all the values, then I would update. Okay, if I store pointer to all records with same values. Okay, then I update the index with this value. Update the index with the pointer to this new record. Otherwise, I already have the pointer to the first record which has this value, and I do nothing else. Do nothing. Okay. So if entry is present in the index. Now let's suppose if entry is not present in the index. Okay, this is the outer else. I would just connect this like this and this thing like this. Okay, if entry is not present and this is a dense index, then we are going to include a new entry and pointer to this new record. Right? And let's suppose if this index was sparse, so for a sparse index, we will just assume that for a sparse index, the index stores just one value per block, and that value is the least search key value. Okay, least search key value, valued record, only pointer to this record we are storing in a sparse index. Okay, so again there is a case if we are adding this new record in a new block. If adding in a new block, okay, then we simply add a new index record and insert this entry in the block. This entry in the new block. Okay, right? Otherwise, if we are adding in some old block, then we again have a case here. If there is already an entry over there, if there is an entry, or rather we won't take this because it is an old block, it is very obvious that there is going to be an index record for this block. So my case would be if this record search value is less than index records search value, then I would update the index record pointer to the new record. Okay, and we would also insert this record in its appropriate block. Else, if this new record search value is greater than the index entry, then we do nothing, just insert the record. Okay, we would insert the record here as well. Obviously, record has to be inserted anyway. We are currently concentrating on what we are going to do with the index entry. Okay, so that was about how to insert a new record. How does it affect an index? Okay, now we will take a look at how to delete a record. Deletion. First we will take a look at dense index. Okay, in a dense index, if the record which is being deleted was the only record with the particular search value, if record being deleted was the only record with that value, only record with that search value, then we delete the index entry. Okay, we delete the index entry and we also delete the record. I won't write it again because that is very obvious. Otherwise, else we update the pointer of the index entry to the next record with the same search value. Okay, so let's realize what is happening here. Let's suppose this is my index and this is my file. Okay, I have 25 here and I have in my file I have a 25 over here, I have a 25 over here, and if I am deleting this, okay, so obviously this is pointing to this. If I am deleting this, then I would have to update my pointer so that it now points to this. and this is deleted. We'll use some other color. This is deleted, right? We are deleting 25 so that pointer also has to be deleted, and it has to be made to point to the next 25 search valued record. Okay, so that was about dense index deletion. Now we will take a look at the sparse index deletion. Again, we are assuming that we are storing least search valued record per block. Okay, so we have two cases. If record doesn't contain index entry, an index entry rather, then do nothing, just simply delete the record from the file, right? However, if it has an index entry, then replace the pointer so that it points to next higher search value in the block. Right? We will just see in a diagram what is happening. Let's suppose this is my block. Okay, it is block. This was file. So, and this is index. So let's suppose I have a record for 25, and 25 is my least valued search key in this block, and the next value is say 26. So if I have to delete 25, then obviously currently it is pointing to 25. If I have to delete 25, then I'm going to delete this and make this point to 26, right? So that was deletion. Okay, so we've covered deletion in sparse as well as dense index. Let's now take a look at secondary indices. We've already touched upon it in the introduction part. We'll just elaborate a bit further on this. Okay, so I'm assuming I have a table which has employee ID 1, 2, 3, 4, 5, 6. Okay, this is my table which is arranged with respect to the employee ID of the employees. Okay, and I have their ages, say 30, 25, 40, 27, 36, 52, and we have other attributes. Currently I don't much care about those. Okay, so I already told you when I create an index on the basis of an value which is used, or rather on the basis of attribute which is used to sequentially arrange the records, that index is called as primary index. Okay, so let's say this is employee ID. So if I create an index using employee ID, that would be a primary index. And if I create an index using age, then that would be a secondary index. Okay, because the age values are not arranged in any particular order. Okay, so if I have to find the person whose age is 40, what is the way out for me? If I don't have an index, I would have to take a look at each and every record. Therefore, if I have to make this operation quicker, I create a secondary index based on age, right? Just understand that a secondary index is always dense. Why is it dense? Because let's suppose I want to find out the person with age 36. Okay, I want to find out this guy, and in my index, let's suppose I have an entry to 27, or rather let's suppose I have an entry to 25. Okay, now I have reached here, but now where do I go? Since it is not necessary that 36 would be down below, it could be up above also, because we have not arranged these records with respect to age. Hence, even after finding a nearer value, it is very difficult to find the correct record. Therefore, we always create a dense secondary index. And other thing is, let's suppose I have another person whose age is 36. Okay, so even now if I have a record, or rather an index record with 36 search value which points to this guy, I won't be able to find this guy who is also 36, right? Because these are not arranged with respect to age. Therefore, a secondary index is having records for all values or all records, or I would rather say search records. It is having an entry for all records with same search key value. Okay, so for all the people having 36 as age, I should have a pointer. So this is it. Okay, so it is dense and it has all the records for a given search key value in its index entry. Okay, also most of the times it is multi-level, right? Because it's already dense, finding a particular record would be very difficult because we have large number of records. So we need to have multi-level so that we can quickly find a particular record. Okay, why do we create this? We create this because we are expecting queries on attributes, or rather on non-primary attributes. Okay, this is not primary key, this is primary with respect to the attribute which is used to arrange the files, arrange the records in the files. Okay, so when I'm expecting many queries like find the employees aged greater than 25 or find employees whose age is between 20 to 40, these kind of queries if I'm expecting, then I would create a secondary index, because otherwise I would have to search or rather look at every record in the file to look for these 20 to 40 employees, the persons who are aged between 20 to 40. Otherwise I would simply, if I have a secondary index, I would simply go through the index and only see the index records which are having 20 to, okay, this is 20 to 40. I would take a look at only these entries if I have a secondary index. Okay.